So welcome to Being a Physicist Lesson 5. So by the end of this lesson we should be able to explain what the electromagnetic spectrum is, describe the differences between waves in the EM spectrum and sound waves, and state the components of the EM spectrum. So the electromagnetic spectrum is a family of waves. They can all travel at the speed of light and they can all travel through a vacuum. And this makes them different from sound waves, which travel slower and cannot travel through a vacuum. They need particles to travel. Now we have a wee look at the electromagnetic spectrum. We can see if moving from left to right, we have radio and TV waves, microwaves, infrared, visible light, UV light, X-rays and gamma rays. And we can see from radio and TV waves to gamma waves, we have increasing energy. Now, an activity that you could do is you have a wee look at your summary notes, and what you could do is complete the picture of the electromagnetic spectrum into your summary notes. What you can do is pause this video and have a go at that now. Now what you can do is click the link below for a BBC bite-sized animation on the electromagnetic spectrum. So as we said before, the EM spectrum is a family of waves. They all travel at the speed of light and can travel through a vacuum. An increase in energy from TV and radio waves to gamma rays. Let's have a look at each type of wave in turn. So let's start with radio and TV waves. Not just for radios and TV, these have other purposes as well. They're used for low orbit satellite communication, MRI scans, and to treat sleep disorders. With increasing energy, we have microwaves. Now microwaves have more energy than radio and TV waves and are used for mobile phones, high orbit satellite communications, as well as cooking foods. Now we're looking at infrared radiation with even more energy. And infrared radiation is known as heat. The picture opposite is called a thermogram, showing how hot objects are. So next in line with more energy is visible light. It's the most well known of all parts of the EM spectrum. White light from the sun isn't actually white, but a collection of different colours of light. So UV, ultraviolet light, with even more energy, comes to us naturally from the sun, and it helps produce vitamin D for our bodies as well as giving us a tan. However, too much exposure can lead to skin cancer. X-rays have a high energy and can be used to see inside the body. The photographic film shown turns black when exposed to X-rays. The bone shows up white because it absorbs X-rays. Gamma rays have the highest energy of all the parts of the electromagnetic spectrum. It is very penetrating and if exposed could cause cancer because it damages your DNA. So let's again revisit this idea that electromagnetic waves and sound waves are different. So EM waves generally have more energy than sound waves. Sound travels at a speed of 340 meters per second in air, and EM waves travel at around 300 million meters per second in air, the speed of light. Can you think and explain why you can see the lightning before hearing the thunder during a storm? Well, this is because light travels faster, and remember, visible light is part of the EM spectrum. Now we're going to ask you to carry out a wee assignment on the electromagnetic spectrum. You'll be asked to carry out research on the EM spectrum, and you can use sources such as a journal, newspaper, textbook, or also any web page you can find to find out more information about the EM spectrum. Bite size is a useful tool as well to use. Success criteria. Let's see how well we did. Can we explain what is meant by the electromagnetic spectrum? Can you describe the differences between waves in the EM spectrum and sound? And can you state the components of the EM spectrum? So what is meant by the electromagnetic spectrum? So really it's a family of waves, a spectrum of radiations waves that all travel at the same speed. They all travel at the speed of light. At what speed do all EM spectrum waves travel? Well, the speed of light, which is 300 million metres per second. The EM spectrum waves travel faster than sound waves. True or false? True. Do you remember the speed that sound waves travel? 340 metres per second. The EM spectrum waves and sound waves both use particles to transfer energy. Is this true or false? Well, this would be false, because remember, EM waves can travel through a vacuum where there are no particles, whereas sound waves need particles to transfer energy. What does that mean, the EM spectrum waves can travel through? A vacuum where there are no particles. The EM spectrum waves do not need particles to travel and can therefore travel through a vacuum. What is the name of the only part of the EM spectrum that can be seen by the human eye? Visible light. List the 7 members of the EM spectrum in order. Start with the member with the least energy. So we have radio and TV waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Let's have a go again. What is meant by the term electromagnetic spectrum? A spectrum of radiations or waves, a family of waves that all travel at the same speed, which is the speed of light. At what speed do all EM spectrum waves travel? So what is the speed of light? 300 million metres a second. The EM spectrum waves travel faster than sound waves. True or false? True. Speed does sound travel? 340 metres per second. The EM spectrum waves and sound waves both use particles to transfer energy. True or false? Well, that'll be false, because the EM spectrum the waves can travel in a vacuum. What does that mean? The EM spectrum waves can travel through a vacuum. What is the name of the only part of the EM spectrum that can be seen by the human eye? Visible light. List the 7 members of the EM spectrum in order. Start with the member with the least energy. Radio and TV waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Now you could do a short activity. I want you to go and get a piece of paper and write down each of the 7 types of waves and cut them out into strips. So you'll end up with 7 strips of paper. I then want you to mix them all up as if it was a card game, and get your phone, and I want you to time yourself putting them in order from the member with the least energy to the member of the EM spectrum with the most energy. Do your best out of 5 and see how quickly you can put them in order.